Hi everyone. In this video, we are going to start learning the first algebraic identity. So, when we talk about learning the identity, it means yes, we need to know that how we have to apply, and application means application with respect to expansion as well as factorization. Okay, so let's start learning the first identity, which is a plus b whole square. So in this video, you're going to learn the proof. Proof as in how it has been developed. Though the proof is not in your syllabus, but it is good to understand that how things or any mathematical expressions get developed. It becomes easier to memorize, to remember any formula, any identity, any relation if you have understood the proof clearly. Okay, so do watch the proof properly. And after that, we will be doing few questions based on expansion of the identity. And then lastly, we will be doing few questions with respect to factorization also. Okay, so let's start. First of all, it is a plus b whole square, right? What is the expansion of the identity that you will be doing whichever question you do? So the expansion is a square plus 2ab plus b square. Okay. Now, talking about the proof that how we have got this relation. So let's start with that. A plus b whole square, it actually means that we are multiplying a plus b with a plus b, right? It is a binomial into binomial. So now what we will do, we will actually start multiplication of a term by term. And when I say that, it means we are going to start multiplying a with a, right? So what we get when we multiply a with a? We get a square. And now I multiply the first a with the second b, and that gives me plus ab. Everything is positive over here. After that, b and a, that gives us plus ba. And lastly, it is b into b, that gives us b square, right? Now, over here, AB and BA, they are same because the order is different in the sense first in the first term AB is written, A is coming first, but in the second term B is written first. That doesn't make any difference. These terms are also commutative in nature. Commutative means whether you write AB or whether you write BA, they are absolutely identical. So when we have like terms, we can simply add them up, right? So what do we get now? We get a square plus AB plus BA actually gives us 2AB. And lastly, B square. Now just from here, we have got the same expression that I wrote on top with the same expression that we are doing in the proof. It is as easy as the expansion. You don't need to do that. In fact, whenever you are doing any expansion with respect to this identity, as we'll be learning soon, if you apply the kind of proof we are doing, you will actually lose marks over there. You have to apply the direct expansion we have developed. That is the magic of the identity that you don't need to do many steps over there. Okay, let's see how. Now, the first question says x plus 2y whole square, right? Whole square means we have to apply the identity. But over here, what is my A and what is my B? X is the A and 2y is my B. Okay, we are doing A plus B whole square. So that means I'll write the identity for your reference. It was A square plus 2AB plus B square, right? Applying that over here now gives us x square plus 2 times x times 2y, and then we have 2y whole square, right? I have written each term by term to show you clearly that how the identity is being applied. So what does it gives us? It gives us x square plus. Now this 2 and 2 will get multiplied, giving us 4, and x and y will multiply with each other, giving us xy. So the middle term becomes 4xy. And after that, 2y whole square. So when we are doing 2y whole square, it actually means we are squaring 2 and we are squaring y as well. That gives 4y square. And that's all. we have just done the expansion of x plus 2y whole square, and we got x square plus 4xy plus 4y square. In simply 2 steps, we have got the expansion. Okay. Now, similarly, moving on with the second part, the question says 2x plus 3 whole square. Now, what is A? A is 2x and 3 is B. So, what we get on the right side now? We will do 2x whole square plus 2 into 2x into 3 and plus 3 square, right? So now 2x square, similar to 2y square we did on top, over here we are doing 2x whole square, giving us 4x square. And now the middle term. Over here we have to multiply 2 into 2, 3, 2 into 2, 4, and 4 into 3, that is 12. When we are doing this multiplication, I have seen many children actually getting confused that the outer 2 needs to be multiplied with 2x and then with 3, or we need to multiply 2 with 2x and along with 3 also. See, what we are doing over here, we are doing a multiplication. It is not that algebraic bracket where you are multiplying a monomial with a binomial. Just see what I mean over here. If I am writing 3 into 4x plus 5y. In such an example, you multiply 3 with 4x and 3 with 5y. Because what is this applying over here is a distributive property. But when we are doing 2 into 2x into 3, there is no property. It is a simple multiplication. For example, if you do 2 into 3 into 4, what will you do? You will have 2 into 3, that is 6. 6 into 4, that is 24. Or whatever order you do, you will get 24 out of there. So similarly over here also, you do 2 into 2x and then the product gets multiplied with 3. So now what we get over here is just 12x. And after that, 3 square is 9. So the answer is 4x square plus 12x plus 9. Okay. Now, the last question on the screen. We have 4x plus half y whole square. We know the first term 4x is our A and second term half y is our B. So applying the identity now gives me 4x whole square plus 2 into 4x into half y plus half y whole square. Now what is going to be the square for 4x? 16x square. In the second term, this 2 and 2 will get cancelled out. Okay, so what are we left with? We are just left with 4xy and the last term, half square is 1/4 and y square comes over here. The way 2 square is 4, similarly, half square is 1/4. Okay, so the answer we have got over here is 16x square plus 4xy plus 1/4 y square. Okay, so over here we did 3 questions with respect to expansion of our first identity. Now, moving on with the next set of questions, you will not find many variety over here, but these kind of questions do appear seldom in your school exams. So what do we need to do over here? The question says find the value. The first one is 101 square. So 101 square, actually what we can do, we can break it apart and break it apart in such a manner that we can apply the first identity. What we need to do, we need to find a number which is closest to tens or hundreds, right? And obviously 101, it is closer to 100. So how can we write? I can write it as 100 plus 1. And it was a square outside, so it still remains a square outside. After this, my 100 becomes A and 1 becomes my B. So applying the identity now, what does it gives us? It gives us 100 square plus 2 into 100 into 1. Though I don't need to write 1 over here, but since we are doing the question, it is good to write it explicitly so that you don't get confused anywhere. Okay. Now B square, which is 1 square, right? And guys, also note that how I'm using the brackets. Whenever you're doing maths, do not be miser in actually using brackets. It helps you. So 100 square, that is 10,000. After that, 2 into 100 into 1 is 200. And then 1 square is 1. So what we get is 10201 as your answer. See, the question was 101 square. I know every child, everyone gets scared when you have to do long multiplications. But applying the identity on such numbers actually makes easier to solve. Okay. Now, the second part, 20.4 whole square. As I told in the previous one, we need to break the number closest to the tens or the hundreds. So over here, what we can do, we can break it as 20 plus 0.4. Outside it's a square, right? Now applying the identity. It gives me 20 square plus 2 times 20 times 0.4 plus 0.4 square, right? So now 20 square is 400. Then 2 into 20 is 40. 40 into 4, I'm not doing 0.4. 40 into 4 is 640. Now we had one decimal. So the 0 out after 640 will finish and we are just left with 64, right? And sorry, it was not 64 but 160. 2 twos are 4, right? And 4 fours are 16. So we are left with 16 over here plus 0.4 square. What is 0.4 square? That is 0.16. The number had one decimal. So when you square, the square answer will have two decimal places. Okay, do remember that rule. Now just the addition left. 400 plus 16 becomes 416.16 after that. So my answer is 416.16. It became so easy to find the square of 20.4 using the identity. Okay. Now, the last set of questions, factorize. Factorization is highly important, be it for class 8 or 9th. And factorization doesn't end with 9th. You will always find the usage of factorization in 10th, 11th, 12th, and whenever you are doing maths. Okay. Now, the question over here says 49x square plus 28xy plus 4y square. The first rule, please understand how you need to recognize that this question applies the first identity. Because we have got two terms over here which are perfect squares. 49x square is a perfect square and then 4y square is also a perfect square because the identity of a plus b whole square had a square and b square. So we have got our a square and b square. Now the middle term, we will sort it out. And also all the terms are positive due to which it is nothing but the first identity. Okay, now let's start writing. So when we write about 49x square, it is a square of 7x. So we write it like this, 7x whole square. Then I am not writing middle term first, but I am going to write about the third term, that is 2y. Now, writing the middle term. For writing the middle term, what we are going to do, it had to be in the form of 2ab, right? So I'll write 2 first. Then we have seen that a is 7x. So I will write 7x over there. And then b is 2y, right? So what we did, we actually understood the first and the last term, according to which we are devising our middle term, right? But before we move on further, let's verify that is the middle product actually giving us 28xy. So 2 sevens are 14 and 14 twos are 28. X into y, that is xy. So yes, we have done everything correct. And now what do we get? We get 7x plus 2y whole square because it has to be in the form of a plus b whole square. Okay, we have got the look of the identity. However, the question says factorize. And 7x plus 2y whole square are actually not with respect to the factors as yet. So what we are going to do, we are going to write 7x plus 2y in one bracket, and repeating that in another bracket actually gives us two factors. First factor and the second factor. So this is how we have applied the first identity of a plus b whole square in factorization over here in a simple question, right? Now, let's try another one. The question over here says 9x squared plus 2xy plus 1 by 9 y squared. The process remains same, where we have to identify the two perfect square terms, and we can see that 9x square and 1 by 9 y square are those terms, right? So let's start writing their square roots actually. What is going to be the square root for 9x square? It is 3x, right? So outside we will write square. And similarly, for the third term, it is going to be 1/3 y whole square, right? Now we will devise the middle term, which is 2 into 3x into 1/3 y. Okay, now we need to verify from the middle term if we are getting 2xy or not. Guys, we are not doing any simplification, so you will not cancel out anything over here, but just do it orally. That is 2 into 3x is 6x. 6x into 1/3 y. Basically, 3 and 3 will cancel. So we are left with 2 into x into y, that is 2xy. So yes, that ensures we are on the correct path, right? Now, just writing in the final form of 3x plus 1/3 y whole square, right? And now we're doing the factors 3x plus 1/3 y. First bracket, second bracket again same, 3x plus 1/3 y. So we got our answer. I hope it's clear, right? Now the last one. The question here says 0.04 p square plus 0.2 p plus 0.25. In this question we can see only one variable, but we can see we have got two perfect squares. The first one being 0.04 p square and then 0.25. Though the three questions for factorization I have written over here, all the questions are in the ideal format of a square plus 2ab plus b square. But it is not necessary that you will get them like that. The terms may get shuffled. For example, there may be a term there may be a question which is written like 0.04 p square plus 0.25 plus 0.2 p. Shuffling the terms actually doesn't matter with the question. It still remains a factorization quotient belonging to the first identity because of two things. First, we have got two perfect square terms. Second, all terms are positive. Okay, now we'll start with the factorization, and over here we are going to factorize it with respect to the original quotient only. So we have 0.2 p whole square, because when you do the square of 0.2 p, you will get 0.04 p square, right? Now, what is the square root of the last term for 0.25? 0.5. Okay, so 0.5 whole square. In the last, we will have 2ab. A is 0.2 p and b is 0.5. Verifying means, what is 0.2 into 2? That is 0.4. Okay, I'll write it over here, 0.4. And when you do 0.4 into 0.5, what is that? 4 5s are 20. But you have two decimal places, so you get it over here, and that is 0.2 p, which was the middle term in the question, right? So we are getting the correct thing. Now, what do we get? We get 0.2 p plus 0.5 whole square. Now making the factors, 0.2 p plus 0.5, 0.2p plus 0.5. And here we ended the question after making the factors. So guys, that's all with respect to this video, with respect to the first identity, because over here we have learned everything with respect to it. We learned about its expansion, the proof, we did questions where we expanded using the identity, found the values, numerical values of certain questions, and then learned the factorization also. In the video, I will attach the video for the link for the next identity as well, which is going to be a minus b whole square. Till then, happy learning.